and welcome to the lecture on irrigation engineering. Today we will study about soil, water and plant relationship. Let's begin. Water for plants. Plants or crop need water to grow and they get it from the soil. Okay. Irrigation water is supplied to the field, gets held as soil water and later utilized by the crop. Okay. So if plant cannot grow without water, and if there is a lack of water in the soil, we apply it manually or artificially in the form of irrigation. Okay, so moving on. Soil water zones. So we can find three zones in the soil: gravitational water, capillary water and hygroscopic water. Gravitational water is the water which drains off under the impact of gravity as soon as we apply it. Okay, so if you are irrigating the field, then the gravitational water will soon be drained off after some time. And second is the capillary water. So capillary water is the water, assume this is the ground level, this is the water table level, then the capillary water rises from the water table to the root level with the help of capillary forces. And hygroscopic water is the water which cannot be utilized by soil. Okay, hygroscopic water is in the form of a thin layer around the particles. Okay, if assume this is the particle, then there is a thin layer of water absorbed by the particles and which cannot be used by the crops. So moving on. Water held in soil. So there are various moisture contents. There's name for moisture contents: field capacity, saturation capacity, permanent wilting point, available moisture and readily available moisture. So let's understand them in detail. Here is a schematic view to represent what are these capacities. Okay, so soil is said to be saturated when 100% of its void are filled with water. Okay, and the water holding capacity of the soil, maximum water holding capacity, depends on its porosity. The maximum, the more the pores will be, the more the water will be retained. Okay, so if 100% pores are filled, then it is called saturated. Then what is field capacity? Field capacity is the water content. It is the maximum water content that can be retained by soil after the gravitational water has been drained off. Okay, and here comes the wilting point. What is wilting point? Wilting point is the moisture content below which the plants will die. This is the maximum water content at which the plants are able to gain the water from the soil. Below this point the plants will die. Okay, and here comes the available water. What is available water? It is the water content between the field capacity and wilting point. Okay, so here you see field capacity is the maximum water that can be retained by soil, and wilting point is the water content that plants can use. So plant are able to use only between these area. Okay, hence this is called available water. And there is another term, readily available water. Okay, so here you can see readily available moisture. Relate it with the previous figure. This is the field capacity, this is the available moisture. Okay, readily available moisture is the moisture that can be easily extracted by the plants. The graph here you see, initially it was this concentration, then it was utilized by plant and the water content fell down. Then we irrigated the field, then the water content rise, and then again it falls due to consumption. Okay, and so let's move on. There is a formula for field capacity. It is the weight of water retained by soil to the weight of dry soil. As I've already told, field capacity is nothing but the water content of the soil. You have already studied in soil mechanics. So this is the formula. Here's a derivation for you. Field capacity is the total weight of water upon total weight of dry soil. Here it goes. We can also write the total weight as gamma W VW and total weight of soil as gamma into V. This is total V. So here comes the formula, simplified formula. Field contains equals gamma W dW upon gamma D into D. which then comes to field content equals gamma w dw upon gamma d into d after cancelling these, and the final formula comes out to be dw equals gamma d upon gamma w into d into fc. And gamma d by gamma w is nothing but the specific gravity, so we can also use it like this. And from here we can also derive the relationship between field capacity and porosity. How? We know that Vw upon V, if the soil is saturated, then Vw equals Vv. Okay, so we can write Vw by V as N. N is the porosity. So field contents equals gamma W upon gamma D into N. Okay, and here comes the final relation. Field capacity by N equals gamma W by gamma D. This is important. Now coming to depth of water at a given capacity. So depth of water at a required capacity, dW equals G into D into required capacity. This comes from the previous derivation here. Okay, so if we have to find the water capacity, depth at the field capacity, then we multiply it by FC. Okay, and if we want to find the depth of water at required capacity, we multiply it with the required capacity. Again, required capacity and field capacity are the water contents. Here's a question from GATE 2013. Irrigation water is to be supplied to a crop in a field to bring the moisture content of the soil from existing 18% to the field capacity of the soil at 28%. Let's mark this 18% and 28%. The effective root zone depth of the crop is 70 cm. If the densities of soil and water are 1.3 gram per cc and 1 gram per cc respectively, the depth of irrigation water in millimeters required for irrigating the crops is. Let's go to the solution. Here it is. Now depth of irrigation water required is equals to, we have just derived this formula, dW equals to G into D into required capacity. Okay, here required capacity is the difference between field capacity and the existing moisture content, W. So dW equals 1.3 upon 1, which is G, into D, okay, 228 minus 18 by 100, and here comes the answer, 91 millimeter. Okay, so moving on. Irrigational water properties. So irrigation water should be clean and free from crop harming impurities. Why this is? If the crop contains impurity, this will be utilized by plant, and when this water goes inside the plant, it will harm. Okay, so it should be clean. It may contain nutrient for plant growth. Here's another term, sodium absorption ratio. Water is also classified based on the salt concentration as low, medium, high and very high sodium water. Okay, here's a formula for sodium absorption ratio. Sodium content upon calcium content plus magnesium content by 2 whole root. Okay, so thank you for watching, and please like, share and subscribe for more upcoming videos.